Located to the north of Pittsburgh in Leesdale, Pennsylvania, Schroeder Industries has been a leader in advanced fluid conditioning solutions for more than 65 years. Now owned by Hydac, Schroeder Industries specializes in research, design, and manufacturing processes of filtration systems for hydraulics, lubrication, and fuel. Schroeder Industries offers part customization for clients that need uniquely manufactured items. Schroeder's various product lines range from advanced diesel filtration systems for the automotive industry to high-pressure ink filters for the printing industry. Schroeder recently underwent a lean training course that led to a lean thinking initiative. Each team member had to complete a project using their new knowledge, which led to the implementation of a Kanban system in the assembly area. Through the implementation of the Kanban system, the assembly station doubled from 3 to 6 stations. However, after this increase, the allocation of parts remained untouched, which led to stockouts and incorrect inventory levels within the system. Our first step in the problem-solving process was to gather data on how often a stockout occurs. What often happened was a worker would place their empty bin at the replenishment station, and a material handler would search for the part to replenish, only to find that there were no more parts in storage. If a worker needed that part to continue, they would often take it from another station in order to finish their filter assemblies, or if that part was out of stock, they would move on to the next order after placing the current order in the short clip area that held unfinished orders. Each time this occurred, it led to increased downtime and decreased throughput. After identifying the root cause of the stockouts being the inventory allocation, we began by creating new standard operating procedures for the material handlers that are in charge of the inventory. We then created work instructions based on the standard operating procedures for both the material picking process and the Kanban replenishment process. We then gathered historical demand data from our mentor in order to analyze the demand of the most common parts. We identified 2 common sub-assemblies called a microswitch and a dirt alarm that were assembled at 4 of the 6 assembly stations and had the highest demand. After ordering the data, we graphed the monthly demand of each part that made up each sub-assembly. We calculated the reorder points and safety stocks of each part based on maintaining enough stock to match their highest monthly demand. Using those calculated reorder points and safety stocks, we developed a bin size for each part in the Kanban system. After gaining approval from our mentor, we began to rearrange each of the 4 assembly station layouts to eliminate as much excess motion as possible. We also used the golden zone idea to limit as many long reaches as possible. In our redesign, we changed out bin sizes based on the size of the part each bin needed to hold. Additionally, we added signage to each bin to ensure that they remained in the correct spot and at the correct station. This was done using a color-coded sticker marking which assembly station the bin belonged to. The idea behind this was to eliminate missing bins or bins being taken to another station to finish an assembly. We then used our calculated fill lines to count out parts and mark on each bin a fill to line to regulate the amount of stock that a material handler will fill the bin with. Afterwards, we evened out the stock in each of the bins to start as a baseline for each bench. After implementation, we gathered data on the number of stockout occurrences at each of the 4 stations. We then compared the stockout rates before implementation to the stockout rates after implementation. Before implementation, we saw that there was an average of 12.8 stockouts per week, and each stockout resulted in about 12 minutes of lost time. Over the course of the year, this wasted time results in $9,762 lost. After implementation, we saw the average stockouts per week drop to 2.3. By changing the work instruction to ensure the material handlers are the workers that refill the Kanban bins, the average lost time per stockout dropped to about 2 minutes of lost time. Over the course of the year, this wasted time results in just over $300 lost. The end result is a savings of $9,443 per year.